Welcome to all of you again to this channel. So in this class we are going to talk about the defects of the eye. So as it is told in the ray optics, there are mainly two defects we are going to talk about. One is myopia. So myopia means it is a nearsightedness, or else it is a short-sightedness we are going to call it is. Mean, for a defective eye, it can see only the near objects. Okay, say for example we have eye, a convex lens is there, it can see the near objects. The far objects it can't see. If the object is far, means because of the defect in the lens, you will get the image before the retina and the image will be blurrier for the defective eye. And this is causes because of the increase in the size of the eyeball, or else decrease in the focal length of the eye lens. Now how we can correct it? So we have to correct it by bringing any of the distant object. Means the distant object you can't see, the distant object we have to bring at the far point. So now for the nearsightedness we have a point called far point. Means near things it can see, the far distances, that is infinity distances, it can't see. So the far point is that this is somewhat little bit lesser than that is infinity. Means the far distances it has to see. So for a nearsightedness, it can't see the far object, but somewhere far distances it can see. That is the near far point it can see. What is the farthest point it can see? The defect eye. That is far point we are going to call, right? For the myopic eye, or else there is a short-sightedness. Now what happens? We are going to use a concave lens of suitable focal length, so that we can correct the thing. So how it is going to correct it? So the eye will be like this, the focal length will be in this way. Now I am going to use a concave lens. So distance objects, images will come, it diverges and it will be on retina. The image will be formed at the retina for that. Now somewhere at this point it is the far point. So your diverged image you are going to get here. So this will act as an intermediate lens, which will give you an intermediate image of the distant objects. Okay, and that will be acted as if like a object for the eye lens. We know that is 1 by f, which is equal to 1 by v minus 1 by u. That is the lens formula. Now for the nearsightedness, we have a point called far point. Means it can see the near things. How much near? One point is there. That is the farthest point in the near objects it can see. Whatever the objects are there, it must be there in that limit. So distant objects we have to bring in that limit. Say the object is at infinity now. Okay, we have to form the image of that at here. That is nothing but at the far point. Okay, which is little bit less than that of the infinity we can say, right? So the formula becomes like this: 1 by f, which is equal to 1 by minus x, because it's a convex lens. Then minus 1 by u. Will be infinity. So minus becomes plus, this becomes 0, and finally we are going to get 1 by f, which is equal to 1 by minus x. And the lens, there is a concave lens we have to use, it must be having a focal length, that is minus x, and the power will be the 1 over of that. That is, this will be the power. And this is what about myopia.